let's learn how to name and write formulas for acids and bases. If you think back to biology, when you talked about acids and bases, we really talked about the pH scale, right? Anything less than a pH of 7 is an acid, anything greater than a pH of 7 is a base. Now we will talk more about acids and bases and go in depth later on in the year. Right now, all you need to know is that acids contain the hydrogen ion and bases contain the hydroxide ion when they dissociate in water. And remember what dissociate means. It means separation of ions when dissolved in water. Now when it comes to writing names and formulas for bases, you'll notice that hydroxide is a polyatomic ion that we just talked about. So when you're naming or writing formulas for bases, you're just using the same method that we used to write the formulas and names for any ionic compound that included the polyatomic ion hydroxide. So for example, KOH is potassium hydroxide. CaOH2 is calcium hydroxide. So we're really just going to focus on how to write formulas and names for the acids. So most acids contain a hydrogen ion that is bonded to an anion. When it dissociates in water, it produces the hydrogen ion as its cation and another anion. So for this table, we're going to write the formula for the acids given the cation and the anion. So in each of these, you'll notice that the cation is the hydrogen ion, H+. The anion is different. We have a chloride, we have a sulfate, and a sulfite. The way that you write the formula is the same as what we've been doing up until now. You're looking at the oxidation number, and you want to make sure that the overall charge of the formula is equal to 0. So what would be the formula for H+ and Cl-? You only need one of each, so it becomes HCl. What about the next one? You need 2 hydrogens and 1 sulfate, so it's H2SO4. And the last one? Again, it's H2SO3. When it comes to naming, acids are named by the anion they form when dissolved in water. For binary acids, meaning when there's no oxygen in the acid, we use the prefix hydro, the root of the anion's name, and then ic acid. For tertiary acids, which means that it has oxygen in it, the name depends on the polyatomic ion. So if the polyatomic anion ends with ate, the acid name will end in ic. If the polyatomic anion ends with ite, the acid name will end in us. So let's take a look at these 3 examples. Acids with no oxygen, and let's say that the anion is the chloride, and we previously looked at the formula HCl. The acid name is hydro, the root of the anion name, chlor, and then ic acid, it's hydrochloric acid. Now for tertiary acids that have oxygen in it, for example sulfate and sulfite, let's take a look at sulfate first. So the acid formula is H2SO4. The ending ends with ate, so we drop the ate and then we add ic to it. So it becomes sulfuric acid. For sulfite, we drop the ite and we add the us, and so it becomes sulfurous acid. Now I'm going to show you how to go from the name to the formula. So we're going to do it for nitric acid and carbonic acid, and the rest you guys will do it on your own. So nitric acid, the fact that it's an acid tells us that there is a hydrogen ion involved, okay? And then nitric, ic, comes from nitrate. So nitrate is NO3 minus 1. Well, how many of each do we need? 1 plus, 1 minus. We only need 1 of each, so the formula is HNO3 for nitric acid. Let's take a look at carbonic acid. Again, the fact that it's an acid means that there is H plus, H1 plus for the cation. Carbonic comes from carbonate, so that's CO3, 2 minus. So how many hydrogen ions do I need, and how many carbonate ions do I need? I need 2 hydrogens and 1 carbonate, so the formula is H2CO3. So go ahead and complete the other problems. Go from given the name, write the formula, and then given the formula, write the name.